we are very proud that you are here to see our center and to hear your presentation.
Professor Radovan, thank you very much and congratulations, because actually, as you said, we are experienced, everybody here is experiencing something that, as you said, in a very sharp way, dream become true. When we started this project, we were quite aware not only of the challenge that we have to face from the scientific and technological point of view, but with the difficulty to involve a so huge number of stakeholders in a project that foresee the support of NATO in building a community in country like Montenegro, which is our friends. Let me apologize with you, because anytime I came to Montenegro, I meet many people that speak very well Italian, and actually I cannot speak your own language, so I'm sorry for that. I hope you will apologize. And anyhow, I tried to build my presentation in a way that might be very visual and easy for you also to understand and also to perceive the meaning of the presentation by visual content. The topics is, in certain extent, is how we exploit the use of 3D, three-dimensional geographical information system, how to enhance the resilience, the capability to react of a territory, of a country, a province, a region. And we would like to demonstrate this statement through a number of presentations, also video and project that we are bringing forward. Also a great example, the one that we had with the GEPSUS. I'm also very glad to see a company that belongs to our community proactively participating to the exploitation of this great project. To give you a very easy understanding of the overall presentation, the idea that I'm working on is how to exploit the knowledge, the information into knowledge in order to support the decision-making process. That for guys like you is basically related to analysis and synthesis. And what I will present you, as I said, in a visual manner, is the result of a combined action that actually I'm coordinating at the European and NATO level as well. So it's a number of years. Everybody knows very well that there is a very strong interest in collecting and integrating geographical information. Why so? Because geographical information are fundamental to control the territory, to understand the situation that might happen in a territory. They might be natural disasters that are affecting our society, might be social situation, or even much complex situation as we are unfortunately experiencing nowadays, which they require significant investment. And this growing is not only related, let me say, unfortunately, to situations that are affecting our territory, but are very important for our society. And they are driven by those global trends that are affecting our planet since a number of years, mostly related to how humans interact with our planet. So the increasing of world population, industrial development, fortunately poverty, and the climate change. And we know how this affects our environment and our society from the economical point of view. There is a very global, at the planet level, effort in exploiting this discipline. And this discipline is not a matter only of computer scientists, it's not a matter only of geography, analysts, engineer, but is a sort of holistic approach that is strongly required in order to improve the quality of life at the global level. And two are the most important institutions at the global level working on that. Global Earth Observation, and more precisely the Global Earth Observation System of Systems. So, I will show you, as I said, this presentation will try to be as much interactive, as much as visual, and there is a discrepancy in this slide. So, is this a future scenario or the actual state of the art? And let me show you what I mean. So basically, we can collect information through aerial survey, might be helicopter, satellite, and nowadays drone. And we are able to collect information in a very precise way that can also cover large part of a geographical area. And it's very important to process those information in a way that can be useful for you guys. So we have to, oops, sorry. I'm always making mistakes. So basically, just to interact, as I said, a survey with an airplane or a satellite can make a picture for the territory that we would like to control, and then this picture might represent visual information like a picture is, so the so-called orthographic information, or might be more geometrical interesting information like the so-called digital surface model. It's nowadays very important to be able to transform those information into knowledge and to deploy product for you guys that are the ones that have to operate in the field. So one of the challenges that we are focusing is to organize this information in a way that might be easily processed and transformed into a product for you. But the problem is transforming information into knowledge. So in principle, when we experience a navigation through a software like Google Earth, we always see some nice picture overlapped in something that we call the triangle soup. So a mesh of triangle. But we would like to know what, not only from the visual point of view, is behind those information. And this portion of the video is really supporting you on that. So basically, we would like to identify objects that are placed in our planet and to retrieve them. And as I said before, we would like to build those information in a way that might be easily to manage from the three-dimensional point of view. And they can be amazing realistic, like the video that you are going to see here, but it's just computer-generated video, and not only a video, it's an interactive system that might be very important for you to make operation in the field, to plan them accurately, in a curated way. And you can make simple operation like this one, like a measurement, in a very easy way. So 3D mapping, rapid 3D mapping, offer you a lot of possibility, like situation awareness, in operation, when you have to define and identify tactical scenario, simulation and training, so how to understand how a situation might evolve in the near future, and also how to train you guys in a situation that might be complicated. Or in urban environment, like we are focusing in the GEPSUS project, for instance, to calculate the line of sight, so when an object is visible or not. And last but not least, when nature might create or generate situations that we have to face in our country. So in the case of disaster analysis and so on. But in principle, thanks to the development of the technology, you are quite familiar with how and to manage this information. Thanks to software like Google Earth, Bing from Microsoft, very well known also piece of software developed by our friends in India. They can be even much more friendly with our Maro, actually, let me say. And the NASA Whirlwind that has been developed by NASA, and is one of the great piece of software that most of our community is using to deploy very specific application. And the idea the whole idea I described to you so far is so-called a digital Earth. So a representation, a three-dimensional digital representation of our planet that allow us, as you know very well with Google, to navigate in this virtual world, to zoom it, to pan it, and also to understand the situation. But of course it's not everything similar to Google Earth. It's a sort of new metaphor to represent information. We are quite familiar to search on Google via textual information, but what we would like to do, and what we are all trying to do within this community, is to have and to build a planet geographical library, where information might be retrieved from a guys like age to 10. So very transparent to the user, accessible through different mechanisms, supporting protocol, standard protocol, made by international organization. And this idea, from the technological point of view, might be very far, because it all started in January 1998, thanks to the speech that Al Gore made at the symposium from the Digital Earth. But from another point of view, I mean, you will understand that it's only few years, even not 3 decades ago, that we start to work like that, and in this scenario. Now, what are the new challenges? For sure, one of the challenges to represent situations that might evolve over the time, so dynamic situation, and also the capability to, if the scope and the goal is to support the decision-making process, to implement simulation, so to evaluate how a scenario might evolve thanks to a what-if metaphor. So a sort of simulation engine. So far we have very much concentrated at the global scale to represent our planet, to zoom it and so on. But we have to understand that one of the most critical areas that we have, especially in the west part of the world, are the urban environment. Usually situations happen, especially in our part of the world, not in the urban environment, but bad guy can focus their attention where we develop our economy, where we improve the quality of life, where our family are living. And we know that there are very bad guys focusing. 11th of September is something that we all have in mind, that they are focusing to bite us in our city. Well, we can also think in a more proactive way. We can guess and we can easily understand that the development of what we call a smart society can still improve the way not only how we live, so the quality of life, but also how we are taking advantage of the resources that are available for our planet. So the possibility to build ubiquitous data and services might make the territory more livable, more efficient, and as I said, more sustainable. But of course, better clever city will not be the better one. That's what we also know very well. And let me give you another visual representation of how technology can improve the quality of life or the way how we live in the city. It's very broad, it's very affecting our society. This is also another project that they manage at the European level, which is stressing on novel interaction metaphor that can help us how to manage with our environment. So, this is a very nice video which is made by Corning. Corning is a very famous world company building crystal glasses, the one that we have in our smartphone. And we might imagine that this tangible interface are very much important in the way how we can interact with physical place in our urban environment. For instance, to how to manage and improve our transport. Or, and this is also very interesting piece of video, how we can further collect information. So, a lady, while a girl, while is driving a car, she can interact with the mirror, with the glasses on the car itself, tagging the information that can be later on connected with the system like you experienced so far today. So basically this presentation, as the last piece of the video, is foreseeing the convergence between virtual information and real information in a ubiquitous space. So what we call it usually shared global information environment information system. And the key requirement, to summarize them, is first of all to share an ethics, not only from, let me say, a green perspective towards our environment, towards our planet, how we would like to, let me say, to live all together in this nice ball. We have to build the software that are able to fulfill the capability to coordinate and joining operation, and the knowledge embedded in this information system should be able to be shared. So, and this should be possible, so the analysis and the synthesis activity that we would like to perform in this environment should be able to give us the possibility to go from a micro scale to a micro scale, from the global to the local. And I will show now a piece of video which is very old, probably 5, 6, even 7 years ago, and was one of our first deployment of our technology. Just a second, I open it. So, the idea was, at that time, to combine a number of very important user requirements. So to let the user to visualize those so-called geographical information, to interact with them, so as we are very, very familiar nowadays, but to let him also to aggregate and generalize information, to let him to create specific information, and to build services, so these processing services that are able to integrate the information that we would like to visualize and work with them. So the initial idea was, okay, navigation, and this is quite clear. But then let me also to access to a so-called federated infrastructure database, so to a pool where I can collect and retrieve information. And one of the typical problems that you know very well is that geographical information are not always represented using the same coordinate system. So one of the processing functionality we have to develop is, okay, I'm looking for a specific piece of information, but I want this information be projected in a geographical manner, so lat and long, independently from the coordinate system where this information is coming from. And this is an example, so the user can open a file, basically, select the coordination system used by the one who generated the information, and visualize this information. Now, a very simple piece of information like the one that I showed you before, so border of a municipality, can, from the visual point of view, contain very few information. is a border of a municipality, nothing more. But indeed, what we can retrieve behind this very simple geometrical information is much more. So, percentage, number of the amount of the population, the amount of the population split by gender, the location of the main municipality, and all those information usually are stored in a table, like into a database. So one of the most important capability to offer to the user is to, as I said at the initial of my discussion, is to let the user filter the information that you would like to visualize and let him represent from the geometrical visual point of view in a very easy manner. So here the user can select a specific filter, even apply some mathematical operator, and then apply the query to the system and visualize it accordingly. And the operation, as you can see, can be absolved in a very easy way. Another piece of information that we consider very important are dynamic information. And what are those dynamic information? One example, as we highlighted in GEPSUS, are the weather information. So information that will be collected by meteorological station. So basically, the meteorological station can be a sensor that is displaced in our region. And we would like to pick, now this is represented in a visual manner by a sort of antenna, we would like to pick on the sensor, independently of the nature of the sensor itself, can be a video camera, and visualize the information behind the sensor. And those information are actually displayed like a sort of cake. And each piece of the cake is, in this case, representing the information that are available from the sensor itself. So being the sensor, in this case, a weather station, we can retrieve information like temperature, humidity, and so on and so forth. But those information, we know very well, are changing over the time. So the user can pick on each piece of the cake and visualize the dynamics of the information itself, which is the evolution of this information across the time. So basically, in this case, we have been picking in the amount of precipitation that have been affecting this specific area, and we can collect the amount of precipitation in millimeter over the time. And this is an example how we can manage information that are by nature dynamic. But now, let me give you an example of, and as I said, this is very old, as you may perceive from the look and feel of the application. How we can implement a what-if scenario. How we can implement a situation that might be the results of how we can implement a simulation, yes, as I said, that is the result of specific reasoning activity. So, the user can navigate in his three-dimensional environment. The user can take advantage of a number of operators that are processing the geographical information or even not geographical information that is available, and then orchestrate, so chain different pieces of processing services all together in a way that we can perform a real simulation. In this case, actually the user would like to perform the simulation of floods in a specific area. The user will select the area where his simulation has to take place, will search for specific sensor, retrieve the information from the sensor, attach to those information to a simulator that is foreseeing the scenario of floods, and eventually, should this operation be very much complicated? Not at all. and eventually which is the most important information that the operator that is working in the field would like to know. We would like basically to know, as example, the number form of the citizens that are affected by the floods. And you will see how this is working with the very few mouse click. So the user is actually instantiating those black boxes that are representing the reasoning. So the information that the object where this information will be processed is chaining them. So it's going to connect the different black box in a way the simulation can take place. So a different amount, a huge amount of simulation or different simulation can take place. Once the data are chained and geographically located, the big processing is going to be processed, and at the end of the day, what came out on the screen is the list of the address and number form of people that are living in this place. So this was what 7 years ago we did it, and this was the first implementation of this idea, or let me say this concept. So basically, to summarize, we would like to visualize free geographical information, to represent also building in a realistic and three-dimensional manner. We would like to fly through this information, as the picture is going to show. But indeed, we would like to support the decision-making process. And for those people that are in the field, they know that one of the key aspects to play with is about interoperability. Because everybody has his own language, not only when they are speaking, but also when they are storing their information. And this is not affecting different country, different region, but even different agency. So how soldiers are storing and collecting their information, how the brigade fire, and so on and so forth. And we have to be able to connect different providers. So that's why during my first initial slide I said something like that we have to be able to build a so-called federated infrastructure in order that information can be retrieved according to specific privilege or security layer. And of course, this has to be implemented in different scenarios in order to catch the requirement and the needs of the different authority and agency working in this field. In an urban environment, what is very complicated is to build the reality as it is, because it's not anymore a problem to reconstruct a geographical environment which is composed by different morphological aspects like desert, mountain, shoreline, and so on. And this, oops. And therefore, we have to be able also to reconstruct an urban environment, which is a very complicated scenario, not only for the building, but for the communication infrastructure, for the road network. And this can be a very intensive effort. And for doing so, we have to take advantage of the information that have been already collected, even though in a bidimensional manner, by different authorities. So cadastral information, information that have been stored by different, let me say, agencies, like the Minister of Transportation, for instance. So in our system, as in many other systems, I have to say, those information may be collected, stored, accessible via the standard protocol, and we actually are using this information, and how in this video we'll show you how, in a very simplistic way, how the system works, to build also the urban network of building. So we use basically the cadastral information together with the digital surface model, and we are nowadays able to represent vast portion of territory, so visualizing them, as you, I believe, also experienced this morning with our friends and their software. We can overlap to the three-dimensional information, the cadastral information, so who are the person living there, information that might be important about the use and the consume of gas, energy. And we have been doing this, actually, thanks to European project, for a different number of countries already. We are, in our project, Austria is taking part with the city of Vienna, UK with the city of Newcastle, Zagabria is taking part of the project, and of course we can share it, and this is very, very interesting. We did a specific customization for Carabinieri in Italy, where the user can not only visualize the geographical information, the shape of the building and so on, but can, while picking on a building, retrieve very important information, like who were the owner of the building itself, the one that were living there, for instance. Fiscal information that are very important in our country because we have to collect those money. We can also represent in a punctual manner information that have been stored by specific operator on the field. And I believe that we have also some very nice representation of a specific activity we did in GEPSUS, which is about the simulation of a flood. Is a simulation of dispersion of gas in an urban environment. And this is very important. This is very sensitive. And this is something that we did thanks to Radovan support in our project. So we can simulate the dispersion of gas inside a city and see how the dispersion of the gas is affected by the 3D building itself. And the different level of the color will give you also the understanding of the density of the gas itself. Now, I want to also present more in detail the result of what we did in a project so-called iScope. And to make my presentation more interesting also for you, I have a video which is actually aiming to present the whole project. And sorry if even this video is in English, but it's very visual and you will understand it for sure.
new Europe is growing. It has strong spirit and deep roots in the territory and in people's life. It is Smart Cities Europe, the pattern of the future city, where spaces become people-orientated, where development is sustainable because it respects the environment, and in which quality of life drives the to-be undertaken actions. Europe has decided to face and win our time's emergencies: population growth, traffic, pollution, access to primary resources, food, water and energy, and climate change. Capitals, there are other cities and whole territories running towards new growth patterns. Trentino, Vienna, Newcastle and Zagreb have chosen this new pattern, creating iScope project. The project, granted by the European Community, aims at widening smart cities networks, led by human beings and integrated by technology, to territories. iScope will make Trentino a smart territory. The challenge is to make Trentino grow without distorting its identity and at the same time safeguarding traditions and social patterns. Tomorrow's Trentino is going to be a territory balanced between city centres and suburban areas, between citizens' needs and demands, between quality of life and environment. iScope, thanks to Fondazione Graphitech and to Informatica Trentino, will make Trentino, its small cities and valleys, experience a new life on a 3D platform. Moreover, thanks to the new tri-dimensional power, the development of new services for citizens will be possible. The city lives a new life and gets lively through graphics that render the depth of volumes and collects information on each single building. These are precious data which, for example, iScope will provide to Trento's municipality in order to evaluate the energy potential of single buildings. Thanks to an advanced database to house building values and to sun exposure of buildings, iScope will allow the administrative board to decide dedicated energy policies for each building. Smart City also means services for elderly people and for people in difficulty, partially sighted people and individuals with disabilities. iScope will map streets, squares and parks, so providing these users with the best path, clear of architectural barriers, to reach their desired destination safely. Technology and internet support a smart city and territory. Optical fibre is assuring speed, but also effective services accessible by anyone. iScope is going to develop a mobile app that will transform people, thanks to their smartphones, into sensors for measuring noise pollution at city level or any other place in the territory. The geo-reference system will transfer noise values on a 3D map. The whole urban territory will experience a new 3D life. iScope project can count on 22 European partners and will last 3 years. Informatica Trentina has involved Trento, Cles and Alas municipalities, social cooperatives, valley communities and public agencies, the energy and the environmental protection one, apart from services and departments of the autonomous province of Trento. Trentino is facing the challenge of innovating itself and becoming a smart territory, where environment, individuals and technological innovation are more and more integrated for a better quality of life. Third millennium's Europe is already here.
the last part of our presentation will be the most dynamic one, hopefully. And we have prepared a demonstration of what we would like to, what we have so far implemented. And as you know, when you have to show something, it's always a bit critical, but we are confident that everything will work as we expected. So basically, this is an application very similar to the one that our colleague presented this morning, embedded into a web browser. So something like Mosaic, Netscape, Chrome. This is the first page that you will experience if you are trying to use our application. And those are the partners that have been involved so far in the project. And Marco Soave is the engineer, which is actually the team leader of the project. Then the look and feel of the web page is basically this one. What you see here is the graphical context, so where all those three-dimensional information will be visualized. And on the upper part of the screen, you will have the possibility to interact with a number of tabs that are basically number of customization of the application we developed so far. One is related to they all have a very social dimension, so they are not so much related with the military sector. One is about the capability to calculate from the shape of the roof the solar irradiation of the sun on the roof itself in order to calculate the potentiality of each building to collect solar energy. And eventually, once that we have this information at the regional level, we have a very, very important piece of information for our policymaker. So basically, the policymaker, they have a precise and quantitative information and understanding of the total amount of energy that can be derived from the solar in the whole municipality. Actually, you see this nice picture, which is representing the solar irradiation in the whole municipality in one specific time of the year. We, of course, calculate this map for the whole year, and then we have this very important information. And let me say that one of our major contributions was to make this calculation very fast. Let me tell you just a number in order to be much more precise. For the city of Newcastle, which is a medium city, a couple of million, it took actually, before we started, 60 days to calculate the irradiation map. We nowadays take advantage of specific graphical take advantage of the potentiality offered by graphics board, and we calculate the map actually in few hours, so in less than 1 day. Now that we have this information, which is very important, which is very much related with the urban environment, what we can also do is, okay, a specific owner of a building is willing to put solar panel on his roof. Then we developed a specific application. If it's work, I see Marco worried about that, because of course there is a laptop, small laptop in internet, and this is also very interesting, this application, because usually we are guessing that this smart technology may affect only very big city like New York, Vienna, Newcastle. This is a very small village in Trentino. It's even less than 1,000 people are living there. And we built this map for them. And actually, each owner of the village, let me call it in this way, because exactly it's a village, can pick on his building and then decide with our application, thanks to very simple button, you will see. First of all, which is the portion of the roof that you would like to cover, 20%, 50%, 50%, 100% of the roof, which kind of specific technology, which kind of, we call it in Italy, which kind of class, okay? Upper class, middle range, so of solar panel you would like to put on the building itself. So you see, for instance, the information that have been calculated. This look a bit too much technical, but this is very easy to understand, is the year, and then the amount of kilowatt per hour per square meter over the time, so January, February, March. As you can understand, this is not only matter of the position of the roof in the urban environment, but how the building itself is surrounded, if it's surrounded by a closed mountain and so on and so on. The orientation of the roof and some more technical information that you can retrieve. And then, so thanks to the simulation, so you can pick, as we said, the building, and then you can decide the coverage of the panel, the efficiency of the panel, what I said before, how much it costs, the so-called acquisition cost, the energy cost, how much it costs the energy. At least in Italy, there are several companies offering and providing energy, and at the end of the day, the software will prepare a sort of PDF, where is a sort of offer or technical offer that give you the technicality of the information itself. And it goes without saying that we can collect the system that we have developed with the small company that are providing these services. So geographical information matter not only, as I said, to improving the quality of the life. We have a smartphone, we are smart guy, for much serious things, as we stated at the beginning. So how to make our territory much more resilient against threat, but also how to face the sustainability of our life towards the planet and the users of the planet, the use of the planet we are trying to have. This is another scenario is about noise pollution. We did it because noise pollution may affect in a negative way the quality of the life in a small village, but also because it's a very interesting piece of information that have a different relation with the urban environment itself. So, first of all, we know that noise maps usually are calculated by municipalities only in specific areas. So when there are streets with, let me say, very high traffic, where there are, for instance, industrial plants. So we don't have a much wider coverage of the noise that might affect our urban environment. So, thanks to one of our partners, the University of Brussels and Sony Corporation, we developed an application. It's for free. There are also many others that every citizen can use. Policemen, everybody can use. Basically, you download from internet this, your smartphone becomes just a microphone, collecting the information, the noise around the user. So we try to hear the city itself. And this is very interesting because it's a bunch of value, but then if this approach is followed by many citizens, so what we call it the crowdsourcing, this information might become very relevant from the engineeristic point of view. And therefore, we can retrieve and build what are those noise maps actually represented by small tile colored, and this information is the statistical distribution of the amount that we collected so far in a punctual manner. Actually, all the policemen in Zagabria are currently using this application. We have more than 25,000 measurements in Brussels and in Paris. And this is very, very interesting approach how citizens can contribute to the quality of life, become sensor. So we call it citizen becoming sensor. And we call it also sensor civic. Well, is the routing also available? Last but not least, this is also very interesting what we are going to show you. From the technological point of view, also very quite complex. And is a multi-route model routing information system. So everybody get used with the navigation system. We can move across Europe, across the whole world with those navigation systems, and are very useful for car drivers. What about if we are diversely able citizens? So if our natural capability to move around is bounded to certain situations. But we can be also elderly people. So basically, we developed this system that allows a user, either via mobile application or with our web application, to calculate a routing that allow the user, when it's possible, of course, to reach a specific location. And this path is free of architectural barriers. This was very challenging for us, because all the pieces of information that we have in an urban environment are very difficult to collect. It's not only a matter of building, not only a matter of road, but it's pedestrian area, might be this specific step that we find in our walking area, even the quality of the pedestrian area is very important for those people that, for instance, are using wheelchair. And this has been done this was very much exploited in the city of Vienna. They have very, very much curated three-dimensional cadastral system, but also to approach similar to the one that I told you. So a crowdsource-based approach. We had actually built an application for Android and iOS that it's downloadable for free, and the citizen can collect architectural barrier every place in the world. User can retrieve and download and use this information for his own, or send this information to us. And the accuracy, of course, of this information is very high, because quantify in a very semantic manner the quality and the feature that are characterizing a specific route. And then, thanks to those semantic information, we can use them to provide the useful information for the final user itself, even via audio information. Within this presentation, that you are experiencing the great quality of the 3D model of the city of Vienna, which has been built in the same way that we built the other cities. So we are doing actually the same for Podgorica. Allow me to thank you very much indeed, you, for the patience you had in hearing me, Radovan for the very kind invitation, and I hope you enjoyed my presentation. Thank you very much.
Thank you very much, Raffaele. Now, have you any comments, question, suggestion, or so on? You can ask Raffaele freely, not like professor. You ask him like expert for visualization, and if you have any idea what should be done for your purposes or for purposes for Montenegro, you can ask him, even drinking coffee, even not exactly now. You are free to ask Raffaele what you want.